Just like the slide says, I'm George Gensure. I've been doing some baseling for the last decade or so. Hopefully I'm going to be able to arm you with a little bit of a presentation today that's going to give you some choices and some challenge for the transcription engine if I can manage to talk fast enough to fit it all in. The goal here is to explain what you should expect, what you could expect, and what is most likely to occur whenever you hit a wall associated with remote execution. So why do we remote execute at all? We remote execute because building everything is slow, even with Bazel. But what that means is that being able to build everything on any machine in any context you want, on this laptop, on that TV display, on the smallest PIC-24 that you can imagine, making that available to all of your engineers at the same time requires money, or at least a lot of money. We're dealing with money here today. If you're confused about whether or not we're actually saving money as a result of remote execution, that's the goal. We want to reduce the costs associated with these things by running on shared resources, because giving everyone every single piece of infrastructure on their desk scales to the tune of the end developers. I don't have that much money to give my developers. As a matter of fact, I don't have any money at all. I just write random open source projects. But the point is that we want to centralize that. We want to spend the money where we can make the most difference, and we want to benefit the most people at the same time. We want to also further reduce the cost of what they're building by not building the same thing over and over again. It's been hammered home. I realize this is a remote execution conference, give or take, in terms of the number of presentations that we've done today. So I've got the graph and the highlight for the flow of exactly how remote execution happens from the original document that we used years and years ago to write out the original open source implementation. With remote execution, we end up with efficiency or correctness, choose to. This is not as common a presentation of Bazel's motto, the fast and correct, choose to, as many people would be able to recognize today. But the point is that time waiting for your build, time waiting for the results, time waiting for any answers associated with how your build process is going is money spent. Debugging the incorrectness associated with your build is more money spent. And what you should expect as a consequence of trying to reach into remote execution, reach into remote caching, is pain. I'll be the first to say that. It's painful. It's a painful experience, just like BZL mod, just like rules OCI, just like all the other deprecation that we deal with on a day-to-day basis. This is going to be pain. But what is cool about pain is that pain is usually in most cases, necessary from the perspective that it is weakness leaving the build. The ratcheted improvement that you make on a regular basis to alleviate the pain that you deal with is the improvement that you want to see associated with your build, and you will see it every day, and you will see it immediately and faster with remote execution, right? We make smaller changes in smaller places, and we pull the lever back, and we pull our situation tighter, and we get more bang for our buck and more build for our money. The pain that we experience, though, is relative to a pretty succinct function. It's relative to a function of the remote execution limitations, what that system will provide you, but with some of the choices that you've offered into the build. And we'll get to the choices in a minute for what that means. Correctness on the side of the two choices of effectiveness and efficiency and correctness. Correctness is sort of the easy side of this. The motivation is that developers' machines are swamps. Every one of them has a libz upgrade that they did 10 years ago, and they have no idea why. Nothing associated with this is perfect, but any mechanism that you do, for the most part, solves enough. You will find areas in which your remote execution machine heating up in the data center causes some problem associated with the ability to reproducibly recreate your build, but these situations can be alleviated. A lot of systems work around it and push past it to try and create reproducible environments. So of our efficiency goals, we want to perform an action once per n developers over t. That's the remote execution formula. We only want, for some time horizon of what we want to cache, we only want to do that thing once for all of the n developers that we have, so we reduce that n out of the equation. We get very efficient builds in terms of what we represent. The large clean central machines that can execute more actions than the clients is also a benefit. If I have a cluster with 10,000 cores, I can probably execute things, or maybe ideally execute things, with more cores, more concurrency than an individual client build with 16 or 25 cores. It's immediately going to date this presentation because next year we're going to have 10,000 cores sitting in front of us. Systemic problems are also more easily solved with money whenever we deal with this. That means that you can hopefully throw money at the problem and fix it. Money is a lot cheaper or a lot less time consuming than 6 interns to solve the problem. And specifically, we can design with a time horizon of T with a single vertical associated with what we're doing. The challenges that go into this are that the client behavior can make the individual build slower. That means that anything that you do associated with your build can cost you time or can result in a bottleneck that you can't scale past whatever client you're dealing with. Bazel, Buck, Pants, Top, Make, I don't care. The point is that every time you push your client, it has to be able to keep up with the level of concurrency that you're interested in. Resource competitiveness, also a factor when the remote system comes into play. If you manage to actually deal with a resource or consumer resource that you don't want, consumer resource that is under contention, you will experience some pain associated with how you're executing. And as has been highlighted recently, non-determinism is a significant cause of this, and hopefully we'll be able to get into just 1 or 2 examples of that given the time. Consider, just as a thought experiment, consider all of the possible universe of build as your space. If we then try to divide it by the number of choices that we've made, we've chosen Bazel immediately. That cuts off a significant amount of the build. We've chosen C++ as our language of choice. We've chosen to do some sort of compliance standard acceptance. We've chosen to do Perl or Python. Well, nobody uses Perl, sorry. We've chosen to use Python as an integration for a set of tools associated with us. And very quickly what you find is that the scope of where your problems lie, or rather the amount of work that you have to do, differs from the rest of the universe of people doing work alongside you. Meaning you're going to have a tougher time aligning, associating. We can see that here. Oh, I run on AFS. Oh, I run on XFS. Oh, I run on Buildfarm. I run on Buildfarm. I run on everything else. Do we have unique alignments for all of these things? No, not necessarily. But the point is that this creates the unique environment where when you encounter a problem, you are much more likely to have trouble finding others to review, agree, associate with, and the integrations for this system become extremely custom. The likelihood that someone is doing the exact same build scenario, you are all very, very unique snowflakes is what I'm trying to get across here. The builds that you do are probably never going to look quite the same, and yet we're trying to give you tools associated with remote execution in general where you're all going to be able to use the same API and call it with the same build constructs. Is that always going to work all of the time? No. So what you should expect on the other side is that the remote system, whose job is an incredible management of the number of individual clients that you're dealing with, whether you're dealing with a prem installation with a single company with 10 engineers, or you're dealing with a multi-tenant, multi-instance, multi-regional setup, these things are going to impose limits on you because that is how they are going to continue functioning. They are going to limit your CPU, your RAM, your I/O, and discovering that they don't limit something can be extremely painful. If they don't happen to limit the number of inodes on your system, or the fact that the machine can't really understand 50,000 shared memory segments, it doesn't matter. Like, the ability for your programs doing arbitrary code execution in their systems to affect you, you're going to hope that there's a limit. I had a CS professor in college who just said, you need to be thankful every time you get that seg fault, because if you didn't get that seg fault, there would have been much more significant dire consequences associated with what you're doing. These are implemented per remote execution implementation, so your mileage may vary. Last piece on the non-determinism, and I'm pretty close to out of time. The environment variables and timestamps examples are great. They're emblematic, and they're very clear in terms of the connection to what you're doing. What gets a lot more complicated is things that traverse the graph, things that follow down through other actions, and especially things where a junior engineer has written in Python their code generator to pump out YAML that something else needs to consume, and it ending up out of order, and you get 500 permutations inside of the build, and your code cannot possibly be deterministic, and you get major cache bifurcation. The short answer is, I don't mean to scare you, but these goals are achievable, but you've got to understand and expect that you are going to hit the wall repeatedly. The likelihood that the changes that you're going to make don't make your build better is very low. This is going to improve your build. This is going to improve your experience on the long haul and make your build a lot more scalable, a lot more adaptable. If you want to switch your remote execution system under the hood, it's very likely that tuning to any number of individual systems, whether it's a vendor system or a prem system or you wrote it yourself and hosted it in a cloud system, these things are all very likely to improve the capabilities of your build, and the tools that are available for this are extensive. And then my final plug is for the project that I happen to have worked on, Buildfarm, the Java open source implementation since 2017. We have a whole highlighted set of tools here just associated with observing your builds and observing your actions and the things that you're putting into the build. More than happy to talk about everybody else, and yeah, go make your builds better in remote executing.